Hi, and welcome to the session of exercise 1.5 in which we will deal with some questions which are related with this. Not all the questions, but I will deal some good questions of them. And let me start with the question number 1. Classify the following numbers as rational or irrational. So, question number 1, we have part A, and this says 2 minus root 5. We have B part, it says 3 plus root 23 minus root 23. We have C part which says 2 root 7 over 7 root 7. D part we have as 1 upon root 2, and the last one of them we have as 2 pi. So one by one I will solve them. Say here what funda we have is, we have a rational number and we have an irrational number. I will just denote it by Q dash, irrational number, and the difference of these will be resulting into a irrational number. So this one is a irrational number. What is this? Is a first is irrational. Now second one, first of all try to solve, open the bracket, use BODMAS rule, and root 23, what it will give you, this will be cancelled up and it gives you 3, which is a rational number. Next one we have, again we can just cancel up the things. This will be cancelled up and we have 2 by 7, which is a rational. This number we can say 1 is a rational divided by an irrational will result in a irrational. So it is a irrational number. The next one, 2 times of pi, it is 2 times of irrational and it is a rational. So this becomes a irrational. So out of them we have 3 irrationals and 2 are rationals. Clear? So I'm sure it is clear to simplify them. Next question is simplify. Question number 2, it says simplify each of the following. So first part is 3 plus root 3 into 2 plus root 2. The normal multiplication we do, I am just doing the same thing. You applying the rules, everything I will do. All the mathematical concepts will be applied here. It will be 3 times of, this will be multiplied first of all by all the brackets, terms within the bracket, plus, and now this will be multiplied, root 3 will be multiplied like this. It will become 3 into 2 plus 3 into root 2 plus 2 into root 3 plus root 3 into root 2. It will end up with 6. It will end up with 3 root 2. It will end up with root 3. It will end up with root 6. So this is how they will end up. Okay. So this is one thing. I can take another one. I will take the third part. I will just leave second and fourth part to you. Root 5 plus root 2 and the whole square. So it will be root 5 whole square plus 2 times of this will happen at 5 plus it will be 7 plus 2 root 10. This is how. Now let's come on the another question, fourth question. I will come on the third question. Recall pi is defined as the ratio of circumference, say c, of a circle to its diameter. We know if this is circle is there, any circle, if this circle is there, the bigger circle is there, there's a very big circle is there. Thus, if this is the diameter d1, this is the diameter d2, this is the diameter d3, and circumference is c1, c2, c3. If we take the ratio c1 upon d1, we take the ratio c2 upon d2, we take the ratio c3 upon d3, it always results into the same term, which is called pi. It is a non-terminating, non-repeating decimal. This seems to contradict the fact that pi is irrational. How will you resolve this contradiction? Say, how will you resolve this contradiction? What this pi says is, say, sometimes if say whatever the say radius is what I given is and circumference, and we divide it, it comes to be same, circumference divided by this. So how will you contradict, and how will you go with that? So what will be your answer is? What is your answer will be? Think it. How will you go? See, this is how the contradiction is not like this. This is pi should be irrational because p c upon d is a rational number. But what is happening here is, if you are measuring this length, let's say I measure this length from here. This is not I'm calculating. What I did is, I just, let's say I have taken a thread, and with that thread I just draw a circle and measure the diameter. So whenever I have the length like this is the circumference. I've just put this, I just open that and just take it like this. I put it, let's say this is the point A, and the same other point, this is point B. I put it A and B, I open it like this, and I put it like this. This is A, this is B. I put it like this. So I measure it. Let's say measure it. This is C2. Will it give me accuracy? No, it is not giving me perfect accuracy. And same is going with diameter also. It is not giving me perfect accuracy. So this thing is, whatever I have calculated is not perfect accurate. And maybe it will be accurate up to 2 decimal places, maybe 3 decimal places. I have more accuracy, it will be 4 decimal places. I have 5, 6, 7. It will be up to 20 decimal places, it will be accurate. But still, I'm not very much sure it is perfectly accurate. So this is the reason it can be accurate in this case. If I have very small one, maybe it will be having no less accuracy. But if I have a big one and big circle, I will make it, and then I will take a diameter. So more the length, more will be the point of accuracy will be there. And with that accuracy, I have some more closer value of pi. So this is never be an accurate terms. It will be sometimes approx they will be equal. So this is how why they will be approx equals to pi, but it is not always equals to pi. The more accurate you will calculate it, the more accurate will be your answer. How accurately you are measuring them, this is the accurate answer you will have, because we are not measuring them with a screw gauge. We are not measuring with the help of the screw gauges, so diamond in millimeters. We are not measuring like that. So we are measuring only with the help of a scale. Again, next question. So it is not a contradiction, it is just a simple case, and all they are equal. Now let's say next question is, represent root 9.3 on the number line. So what we'll do is, same question we have done, we just take point A, I will draw a point B which is say 9.3. Then I will draw 1 unit point C. Then I will take 9.3 plus 1 by 2, which is 4. It is 10.3 by 2. Half of that I will take the mark. I will put the markers and I will take the mark of that. This is the half of this. I will put this mark as P. And with that mark, what I did is I will draw a semicircle. I will draw a semicircle here, and with this point B, I will draw a length. This is equals to, this length is equals to this one. This length is equals to 9. It is 10. This is 9.3 minus 1 by 2. It is 8.3 by 2. 8.3 by 2. It is 9.3 by 2. Okay, it is 10.3. And we had this one. It is 10.3 by 2. And this length is the length which is under root 9.3. And with that, I will, this is, let's say, PQ, and with this Q, I will have this arc, and this point from here, this one, I will have this line. This will give me the length of 9.3. Okay, so I will mark the length here like this. Clear? So this is the question on this. Let's say move to the next question of exercise 5.3. Rationalize. What the? Rationalize. Again comes the question. We have to rationalize the things. Rationalize. So the first question is, I'm taking the first part, 1 upon root 7. So to rationalize, what we did, we just multiply and divide the numerator and denominator by root 7, and this is done. Second question, we have 1 upon root 7 minus root 6, and it can be easily shown. We just conjugate of this. One is root 7 plus root 6, and here is root 7 minus root 6, root 7 plus root 6. So it will be root 7 minus root minus 6 is equal to root 7 plus root 6. Clear? Third one, we have 1 upon root 5 plus root 2. Okay, so it will be root 5 minus root 2 over root 5 plus root 2, root 5 minus root 2, and it will be equals to root 5 minus root 2 upon 5 minus 2. It will be 1 by 3 root 5 minus root 2. So this is how I can write. We have the last one, fourth also. I will solve for you fourth. Maybe you will have the problem. So I just rationalize it. But what will be the rationalizing factor of this? The conjugate of this is root 7. Yes, you are right. Plus root 2 plus 2. It is root 7 minus 2. Root 7 plus 2. It will be root 7 minus plus 2 upon 7 minus 4. 2 square is 4. So it will be root 7 plus 2 upon 3. So again it will be the 1 by 3 times of root 7 plus 2. Clear? So we have done with this rationalization. Right. So with this I will come to the end of this session of exercise 1.5, and hope we will meet in the next session of law of exponents for real number. Law of exponents we will do. Okay. So have a nice time. Thank you.